Okay, now let's start. In today's video, we are going to solve some examples of the theory which we have studied in the videos number 1, 2 and 3. So before starting to solve the examples, first of all let me say you about the theory which we have studied in previous videos number 1, 2 and 3. There we have studied about first sets, definition of sets, second types of sets, and third how to represent sets, meaning representation of sets. So here we are going to solve the examples based on these 3 points. So let's start. Which of the following are sets? In example number 1, 2, 3, 4 and 5, we have to identify that which of the following collections are sets. So in this series of examples, first example says identify whether this collection of all days of a week starting with letter T is a set or not. Okay, so we know the days of a week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, and there are days which starts with letter T. Okay, first one is Tuesday and second one is Thursday. So these are the 2 days which start from letter T, and we have to identify that whether collection of days starting with letter T is a set. So first of all, there are 2 days, Tuesday and Thursday. Let's write this in the form of set days. So D is equal to Tuesday, comma Thursday. Actually we have expressed this in roster form. Okay, now by definition we can see that this is a well defined set. Why? Each of the 2 days start with letter T, and there are 2 days in a week which start with letter T. So this collection is a set. Okay, now come on the second example, collection of all difficult questions in the lesson of set theory. In this example we have to make a collection of all difficult questions of the lesson set theory. So here first and foremost thing is that what is the parameter of a difficulty of a kind of a question. So you can see that there is no certain parameter that how can we say a particular question is difficult or it is a easy question. It basically depends on the person to person, student to student, that how he takes a particular question, difficult or easy. So difficulty of a question is not well defined. Therefore, collection of difficult questions in the lesson of set theory cannot be a set. It will be just a collection. Okay, third example, collection of all the rivers in India. We can make a collection of the rivers flowing in India. It means that in this example we have to make a collection of all the rivers which are flowing in. Okay, clear? So this is also a well defined collection, I think. So this will also be a set. Collection of all integers greater than -3. All integers greater than -3. Okay, we know that integers are plus minus 1, plus minus 2, plus minus 3, plus minus 4 and so on. Now in this example we have to make a collection of all integers which are greater than -3. Collection of integers greater than -3 will be -2, -1, 0, 1, 2, 3, 4 and so on. Okay, this is a collection of all the integers which are greater than -3. Now you can see that this is not a finite collection, this is infinite collection, or infinite set. This may be an example of infinite set. Clear? So I think this example was very much clear to all of you. Now, last example in identifying collection to be a set or not. Last example is collection of beautiful flowers in the garden. Again, this example is similar to the example of difficult questions. Beautiful flowers and difficult question. As here, there was no parameter to measure the difficulty level of a question. Similarly, there is no parameter to measure beautiness of flowers. So, this collection will merely be a collection, cannot be said as set. Okay, I think example number 1, 2, 3, 4 and 5. These 5 examples are clear to you. Now, come on the 6th example. Example number 6, we can see that write the solution set of the equation. Let us suppose the equation is x square plus x minus 2 is equal to 0 in roster form. In this example, we have to write the solution set of the equation x square plus x minus 2 is equal to 0 in the roster form. Now, first of all, here, what is the meaning of set? Solution set. Solution set. Now, you can see that this equation is a quadratic equation, means it will have 2 solutions. Okay, solution number 1 and solution number 2. These 2 solutions are the roots or solution of this particular equation. So these 2 will make a set, and that is why here it is written solution set. Okay, again, solution set of the equation x square plus x minus 2 is equal to 0 in the roster form. Okay, now equation is x square plus x minus 2 is equal to 0. First of all, let's solve it. This will be x plus x plus 2 into x minus 1 is equal to 0, which implies that x equals minus 2 comma 1. So these are the 2 solutions of the equation, and we have to write the solutions in the form of set. So therefore we may write as solution set S is equal to curly bracket minus 2 comma 1. This is the answer. Okay, now example number 7, set A is equal to x such that x is a positive integer less than 10 and is an odd number. Okay, we have to express this set in roster form. In this example number 6, we have seen that we have to express a given set in roster form. In this case, the given set was given in the form of statement. So this was the statement form of set, and this x is such that x is a positive integer less than 10 and is an odd number. This is actually rule form. Rule form or set builder form. Clear? Now we have to express this set given as in the set builder form in the roster form. So set A is x is such that x is a positive integer less than 10 and an odd number. Okay, so we can write it as set A is equal to positive integer and odd number less than 10. Positive integer less than 10 and odd 1, 3, 5, 7 and 9. So this is the set of positive integer less than 10 and odd number. Now we have expressed this set which was in rule form in this form, which is roster form. Okay, now we come on example number 8. In example number 8, it is given that Set E is equal to set of all letters in the word trigonometry. Express set E in the roster form. Okay, so now the word here is set E is set of letters of word trigonometry. Okay, clear? So E is equal to, letters here are T, R, I, G, O, N, M, E and Y. Okay, in the word you can see that the letter R and letter T are being repeated, but while expressing in the roster form we don't allow repetition. We just write a member only for once. Okay, so here we have expressed this set which was given in the statement form in the roster form like E is equal to, okay, like this.